Hi, I'm Chris Bradshaw from Hexagon. In this video we'll take a look at the integration between CADWorks, Caesar 2 and GT STRUDL. We'll start with a CADWorks model showing a structural T-support supporting the piping. We can take the piping model, export that out to Caesar 2 and run the piping analysis, which will generate the piping loads acting upon that T-support. We can then export the T-support from CADWorks and export the piping loads from Caesar 2 and bring them together in GT STRUDL. We can then automatically apply those loads from Caesar 2 in the GT STRUDL structural model. My colleague Ravi will take us through how to perform this process.
Hi, in this presentation we're going to take a look at how to check this T-support for these piping loads. So what we need to do is basically export these pipes to Caesar 2 to do the pipe stress analysis, and then export this T-support to GT STRUDL to analyze and design it per the code inside GT STRUDL. So let's take a look at it first inside Caesar 2. So this is the Caesar 2 model that was generated based on the CADWorks model, and we've gone in and applied some loadings. We'll just run the analysis here using this button. After running the analysis, you should see all the design results. So here are the results. Now we can just take a look at maybe load case number 15, all the restraints, and click on this icon to view the results. It'll generate a text report out for us to show us that node number 1060 here, you can see has a force of about 1277. Okay, now we want to take that and apply it to the structure, right? But in reality you might have multiple restraint reactions. In this case it's very easy, so I'll show you how to transfer these results to GT STRUDL. First, what we do is click on this icon called Data Export Wizard. This will allow you to create an MDB file. You just click on Browse, and you can select the location where you want to export this file, and if you hit Save, it'll actually go in and export these results to the MDB file. Okay, so now this is the T-support that comes into GT STRUDL. Now to get the support restraint loadings from Caesar 2, you click on Create and Caesar 2 Piping Load Import, Caesar 2 Piping Import, click on Open, and then you can point to that database that we just created on our desktop. Okay, so if I go to that same folder, you see this MPS Ing1 folder file, and then you can see all the restraint locations, and there's your restraint 1060, right? Now if I click on piping geometry, and let's say we wanted to export that piping geometry to a GTI file, again on the desktop we can do that. We'll save it as piping.gti and just give it a node prefix and an element prefix, just so that GT STRUDL does not create conflicting member. If I say replace that with the new data, you can actually go in and import that piping geometry into GT STRUDL, and as you can see, these yellow lines that you see are represents the piping. If I show you an isometric of it, it shows you the wireframe model of the structure and the wireframe model of the piping. If I render it, this is how it looks like. So it gives an engineer the a schematic of how the piping is oriented with respect to the structure. If required, now they can move, they may decide to move it, but this looks okay, so I'm just going to go in and delete the piping model from the structural model because we don't need it. Now we're going to go in and import the loads. So we go to Create, Caesar 2 Piping Loads, Caesar 2 Piping Import. Here if I go to Match to Structure, our axis of gravity is the z-axis, and we can just say, let's say we wanted to do a search in a 100-inch radius, we have found one node match, a restraint node matching. We can just say map that and save the mapping, and you see now 1060 is mapped to GTS member number 2, and it actually shows you the location at which it found the match, okay, on the member. Now if I go to loads, you'll be able to see that same loading that you saw inside Caesar 2. Here is 1060. Here is that loading of 1277.34 that we had noticed in Caesar 2. We can then generate a loading file and export all those loads to another file, and we'll just say loads.gti. And what this file will contain is a text representation of all your loadings with documentation. So it actually tells you that node 1060 restraint loadings have been applied to member number 2, and these are the strudel commands to generate the loading. Okay. Now to visualize those loadings inside GT STRUDL, you just go to File, Read Input File, and then go to the desktop location and just import that loads.gti file. And with that, what you'll see is the restraint loading has now been applied to member number 2, and there's the loading 1277 pounds. So from this point onwards, an engineer can just go in and select any node point to support it. Okay, I'm just going to create a support, analyze that model for that loading, and then you can see the results of applying that load to that member. Okay, and if I just go in and just show you, this is the animation of that loading. Okay.
Right, well, thank you, Ravi. Now, I hope you found that video useful, but remember, if you do have any further questions, please don't hesitate to reach out to us at Hexagon. Thank you for watching.